Hello, welcome to another coding session. We're going to continue with Bangalang. Super happy with the progress we've made recently. We now have type annotations. So we have 4 different sizes of signed integer, 8-bit, 16-bit, 32-bit, 64-bit. And our language is statically typed. When we compile, that goes to the proper registers for these different sizes. So we're using the correct amount of space and doing the correct arithmetic based on those sizes. We have, procedures, loops, if-else, we have comments. We've got lots of stuff, I feel like. Even nested multi-line comments, very fancy. And now what I'd really like to have a go at, I think I might just change this. I want to make an array. So maybe I want to make an array that has 8 elements. And then I want to access, let's say, element 5 and assign 7 to it. And then maybe assign one element to another element. And then return an element. I think that's a nice start. I think to have an array here, to pass an array in is a little bit extra. I think one thing I'm going to try and descope, or to do a baby step. First, we're going to do just like this. So whenever you use an array, you have to use just one element of the array. You can't just use the whole array. So what I mean is you can't do can't do that. Not yet. Because I think that'll just simplify things a little bit if I don't have to copy chunks of memory. Because at the moment, everything is based on, single registers. So let's try that. Let's try this for now. I think that's quite a lot to start with even. So let's see if we can do that. We're going to need a couple more tokens. Well, maybe we'll start with the grammar, eh? It's always good to start with the grammar. Identify what we're going to do here. So I think this identifier within the primary, we're going to change. I guess there are kind of 2 things, right? I'm going to call it a variable and a type. So this we'll call this a data type. So we'll have a data type. Need to put an escape there. Followed by optionally, it will be followed by an opening square bracket. And we're just going to say a number for now. We're not going to allow expressions in there. That's another thing we'll just do to keep it simple. And then a closing bracket. And I think we can just get rid of this and get rid of this. And we don't need this at the end either. So just like this. A data type. So we never actually defined what type was. We're defining it now. And and now we're saying there's another thing called data type, which we're not going to bother defining. I mean, I guess we could. It's not, data type is not a difficult one. So it's, because there's only 4 options that it could be. So let's just go like that. So that'll be 64 32. So these are all the types we can have. Just this. That's it. So that's a data type. We can have one of these, and then we can optionally follow it by square brackets with a number in the middle. And that will make it an array of that number of elements. The variable syntax is going to be really similar to data type. To type. So just do that. But instead of data type here, we have identifier. So that identifies a certain variable. And then up in our expression, we're going to refer to that variable. So now a variable could be an identifier like it was before, but now it can optionally include square brackets and a number, which is the index. Could that number be an expression? Let's just start with number for now, but I mean, ultimately that could be an expression, right? I don't see why that wouldn't be an expression. And there's this somewhere else. So type is in declaration, so we can declare an array. I'm actually going to make, for now, because remember we said we're not going to allow copying arrays and stuff. So you can declare an array, but anywhere else where type shows up, and I think the only other place is procedures. I'm gonna, where is procedure? There. I'm gonna make this data type. Just temporarily. So that means that we can only pass in like scalars, which is to say single elements, and we can only return them as well. We'll fix that up later, but we'll just put that limitation in there for now. So that's, I think, everywhere that our type should show up. Our variable needs to be used in an expression, as part of an expression, but I think it also needs to be on the left-hand side of an assignment, right? Like this. We should be able to do this on the left-hand side. So this identifier here will become a variable, like so. So some interesting changes actually to the grammar. When it comes to tokens, it's not too tricky. Quite a simple change. We just have a couple extra tokens, a couple extra single character tokens even, which are very easy to implement. Square, square, like so. Now we support square brackets in our tokenizer. And we can get into something a bit more interesting. So parsing. Let's refer back to the grammar. What's the difference? Well, now we have, like, variable and type have their own thing going on. So let's create their own procedures for that. We'll put it above parse identifier. So here we have parse variable and parse type. Give them some empty returns, like so. And a variable, I guess, is, well, it's an identifier, isn't it? An identifier optionally followed by square brackets. So I think we need to say node equals parse identifier, like that. And the reason we're doing node equals, so we're only going to have one node here. I think because the nodes already have type information, right? And I think essentially we're going to add some more type information. So we'd also have like a data index, which is an int. And then the idea is that when we peek and we see a square, I can't do that. What is it? Opening. Sometimes the code completion doesn't work so well. I think it's just some random person maybe has made this plugin for CLion to get Odin working, so some features are not amazing. But so if we see that the next thing, oh, we've got something very similar here. As an opening square bracket, then we consume it. And we consume the closing one because there needs to be a closing one as well. And in between those, when we're dealing with a variable, so that's like this, right? This is our variable. Like it can either be just like num or it can be with an array on the end. So in this case, this number is referring to the index within the array, right? If we have a variable and we're putting this on the end, that's getting the index. So that's why I said we need this data index. And that will be, I guess we need to convert, right, the value. So I said it would be a number. So what in our tokenizer, when we parse a number, what do we actually allow? It looks like we just allow 0 to 9. So there's no decimals or negatives or anything, it's just numbers. So here we can be pretty sure we have a number already. With string conversion. So there are these parse, but I think it's actually if we go, was it A to I? It's a bit simpler because it doesn't have an OK flag and everything. And like I was saying, we can be pretty sure that it is OK. We need to import strconv. And then hopefully it's happy. Yeah. So I think that's how we parse a variable. And when we parse a type, types don't have their own nodes. So I think it's just going to be like we pass in a node and we append type information to it. So there must be some examples of this already, right? Where do we do type stuff? Here we go. I think that's essentially it. That right there. Okay. So yeah, so we're modifying an existing node, the data type, and then also we have this kind of thing going on, right? We could have square brackets, but this is not denoting the index now. This is like the this is like the length, which I think is part of the type. I'm going to say that's part of the type. So let's make a struct for this. Struct, and we'll just call that name and length. like so, and then that is a data type. That's going to probably break a bunch of stuff. Actually, let's not fix these for now, because I think everywhere where it's broken is somewhere that we want to probably use parse type. So we said it was name and index. I'm going to put -1. No, length of 0. No, length of 1 would be the default, right? I think that makes sense. Because yeah, if we don't have these brackets on the end, we've just got a single element. But if we have brackets, that means we have an array, we have multiple elements. In which case, data type.length would get set to that number. Yeah, yeah. And now, because we changed this, so this is our data type. So let's make that also empty with 1, and that's not good enough. Data type, data index. Data index, this is the one. Let me have a look here. Type, value, data type, data index, and then children. So I think I want to set this one to -1, the index, because that should only have a valid index if we are indexing into something, right? Because where we use this data index is when we have something like this, array 5. But if we had something like this, just num, then we couldn't say, or could we say 0? It is essentially index 0, right? Okay, we'll default it to 0 for now. And see how we go. All right, so we've got parse type, we've got parse variable. Now we want to use these things. So parse type, I think only goes in one place, declaration, right? Where's this? This is declaration. Yeah, and this is where we have that error. So I think we just go parse type stream and then the address of this node, because we need a pass by pointer. Just parse type. We have some errors up here. So this is the other place where we have a type, but here we are saying that we can't have brackets. So I think we're just going to go like this. So we have the name of the data type, but it's always just 1. And by doing this, we ensure that the parsing would fail if you had square brackets in this location. And eventually we'll change this so it does do parse type. Oh, just lucky that was an error, because we needed to do that. Okay. So that's the type. Another variable appears in primary and an assignment. I think that's it. Primary and assignment. Primary should be just up here a little bit. Here's primary. So now, previously when we found just an identifier, we just said this is an identifier node. Now we have to do something a little more in depth. I think we might change this into like an else if. Delio, don't need to return. So everything's just going to get taken care of within this else if. So we have another one. It's like, we already have identifier. So we'll make a number one. And this identifier, we'll move this down here because it's got two cases. Parse call. Parse call? Yeah, if we have an identifier followed by an opening bracket, that means it must be a procedure call. Otherwise, it is a variable. Cool. And for a number, I guess we want to do this and this and this. And then we want to have like else you fucked up. You got an invalid token. Let's just put a peak token here so we have something to show in our error message. I'm sure this could be better. So it's not the number. And basically dot value is that. Type usually goes first. So we set a type and a value. So we just restructured this so that all of our, we've got an if else for all of these cases across here. So we've got the call. No, this is if we have brackets around an expression, then we have a call, a variable, a number, or a negation. And that's what all these if else's are. And then if none of those, that means something went wrong. And this is basically what we upgraded from something like this to something like this. Parse variable. Where else did we say we saw it? Assignment. Here's assignment. So it's on the left-hand side. I think it's just like that. I think that's parsing. So probably if we ran that, it would not succeed at all because there's a lot of errors. Okay, yeah, that's because we changed what a data type is. Actually, this is interesting. Probably our return data type does want to be a data type, right? I mean, we're not allowing the return of arrays right now, and we're not allowing parameters to be arrays either. So we don't really need to, let's just do it anyway. And maybe I'll rename this, because everywhere I'm saying data types, so let's say data types. And I'd kind of like to do this. So this is procedures by name. So yeah, even though these are always just going to be one, I think we'll just put it like this for now, and then we can upgrade it later. So they can be something other than one. Yeah, so these hard-coded procedures will return one, and the name is not in there anymore because we have a map. So the name goes like this. Is that it? And also the parameters now need to be objects. And there's just one. Oh, it does not like that. Maybe we need to specify the type. Yes. A little unfortunate. Okay, so exit is just like this. And it's a single I64 that we're passing into the exit. Oh yeah, we need this. Yeah, everywhere we see I64 just becomes a single I64. I mean, add and plus one, we could just get rid of those. Let's just get rid of those because they're like, they were pointless procedures that we just made. You know, they're hard-coded in here. We just made them earlier because we were trying to call procedures before we could define them in the language. But now that's not a thing, so let's just get rid of them. Okay, so now procedure does not have a name thing. Instead, this is where name needs to go. So let's just make a variable called name. There we go. And so this should be simplified. This looks like we're searching for a procedure. So it'll just be procedures with that name. Yeah, that's why I'd been thinking about this for a little while. That's why I wanted to change this to a map, because this is basically how it gets used. So why not? Okay, when we type check the expression, we're going to need to take in a data type. And here it's we're checking to see whether the left-hand side has type information yet. So an empty name would signify that. Again, we just need to change this. And again, it's this. We're going to need to add some more checks around the place for sure. We have to think up what they are. So here we have a slice of data types, don't we? So this is expected data type, like so. And coerced types needs to be upgraded. Oops. So that it deals in data types. Okay. I mean, I could just do an empty object, right? You need to check that it's not valid with the Boolean. We'll still use name as a way to identify the fact that we have set a coerced type, because it starts uninitialized, which means the name would be empty to begin with. And now that it's not, that means we're all good. This is to do with the name. So these are still invalid types that we want to skip over. So basically we're just going in this coerced type. We pass in a few types and then we try to figure out one single type that we can use. So if it doesn't have a name or it has the name number, then they're not usable. And then we have this check here, excuse me, because if we're going through this loop and we find a valid type, great, but then we come around and we find another valid type that's different, well then that's a conflict, right? So we have this here to establish that it's a conflict, but I don't think that's going to work. I think we need to check the individual members now. So the name and the, what did I call it, length? If the name is different or the length is different, then that's a different type. And then we have a conflict. So we return that we failed to coerce. We failed to find a type that will work in that situation. And that seems happy now. Okay. So let's copy this down to here. Quite a few places should be happy now. These ones up here are still not happy. It's because, what is this? This is the if. So this is saying that the result of the if expression needs to be an I64, which is strange. I mean, it should be a Boolean, but I just had to nominate something to use. And that something ended up being an I64. I guess now it should probably be like an I8. Would probably make more sense. Just use 1 byte. But anyway, it is what it is for now. You just pass that through. We still have an error up here. Because primary doesn't know about that yet. Expected data type. These are all data types. Cool. And passing it through. Now data type. So if we have a primary and we found that it's a number, then that's, you know, a number literal is obviously not an array. So we'll just say length 1. Searching for a procedure again. So now we can just do access the map. What's wrong with that? It doesn't have a name anymore. Right. So what does it have? A return data type, which has a name. Actually, because I mean, this is probably valid, right? You could have a procedure that doesn't have a return. It doesn't return data anyway. But now that we've got a map, what we should probably do is just say if this is not a key in the map, then we've got a problem. Yeah, then we can't find the procedure. This is not the best error because it could be a declared identifier. It's just that it's not a procedure. Like it could accidentally be a variable name. So could do with some improvement. Generation has some errors also. We'll just go through and maybe, well, parsing we have sorted. Type checking, we fixed the errors. But I do think there needs to be more, you know, checks now that we have array types. So when it comes to calls, we have established that we can't use arrays. We can't pass arrays, we can't return arrays, so that's not an issue. This here is a variable. So it could potentially have multiple, I mean, it could potentially be an array, so it could have an index. Do we need to check anything? Well, I guess the data type will tell us, whether it's an array. And if it is an array and we have an index into it, this is part of an expression, right? And in an expression we said that we have to index into it. We can't do the whole thing. That was a limitation that we want to do just to make things simpler. So, well, I guess we can do it after this, right? Because now this data type is correct. So we can say if data type dot length is greater than 1, so if it's an array data type, and we haven't indexed into it, which would mean that node dot data index. See, we defaulted that data index to 0, which is a valid index. So I think we should initialize it to -1 instead, if we're not indexing into an array. So then we can say, if this is an array but we're not indexing into it, that's a problem right now. Later on it won't be, but right now that's a problem. Like index required for. Yeah. Like that. So back in parsing, we need to make sure that we're initializing this with a -1. Is that when we parse a variable? Parse an identifier? Yeah, this guy. I think that's it, right? Is there anywhere else in this file that we use that? I don't think there is. And then there's the condition we just made. Is there any other place we use it? Yeah, okay. But I don't know if it counts when you if you do, an array initializer. I'm not sure if it's going to count. Okay, let's just hope that that's correct. So that's a nice check to have. We also need to check whether it's in bounds or not. So if the data index is greater than or equal to the length, then that's a problem. So we said if we're not indexing, it's going to be -1, and the length will be 1, so that will be fine. If the length is greater than 1, then we need to make sure this is less than 1. The data index, yeah, I mean, if the data index is -1, that could also be a problem. But we can't because in our grammar, it's just a number. It can't be negative. So we can't have negatives. So if this is a negative, it means that we didn't index. Okay. All right, I think that's okay. So then we say index out of bounds. I guess we can do %i data index is out of bounds of that value. All right. I'm happy with that so far. Got a bunch of checks in there. When we're type checking our expression, well, we've already established that all of the elements within the expression are not arrays. They could be elements of arrays, but they're not arrays. So that's fine. So this should be all good, I think. I don't think this actually needs any extra type checking. When we do a return, we can't return an array. Do we need to do something? No, well, it's using an expression, right? And the expression takes care of making sure it's not an array. Okay. And also this return data type could not be an array itself. Yeah, when we do coerce types, that takes care of array versus not array. Type check assignment. So when we are assigning the left-hand side, needs to be as a variable. So we have this undeclared. So I guess we need to do the same checks we did down here, right? Where is it? Here. Yeah, we already have this one up there. Now we kind of want to do these as well. We want to make sure that we're indexing and that we're not out of bounds. So this, maybe we'll make a procedure for that. So let's say type check variable. Then this goes up like that. I think this also is a good part of it to keep. Yeah, because in both cases we're going to want to do that, I think. And that means that when we go up to here, that just becomes a one-liner. Like so. Oh, need the context. And that's like that. And then when we're up in assignment, we do the same. I guess it's LHS, okay. What's wrong with that? Oh, we need to declare, and then I guess this can just be the data type of the left-hand side node. All right, cool. Nice, I like that. Declaration. Did we change anything in declaration? Well, this is the type information, but that was there before. The type can now have a data type. I mean, it can have a size. Is there anything more we need to do with that, though? We type check the expression on the right-hand side. Expressions cannot be arrays. In this case, we are not assigning. And we can't assign because of that limitation we gave ourselves. And you know what? I think this is a valid way to declare. So I think we might modify our declaration. So that was a bracket. Here we go. Maybe something like that. Yeah. So this assignment part is optional. I think we don't have to do that. And yeah, right now we can't do it. So I think we have to go back to parsing now. Parsing our declaration, because this part is optional. So let's say if we peek and we find an equals, then we do this. Otherwise we don't. And where else was, oh yeah, that was it, I think. So type checking, that's where we were. So this is the right-hand side stuff. I guess that can go up there. No, but it might That's right. The type information of LHS might come from RHS. So I guess the way we know if there's a right-hand side is with the length of the children. If that's greater than 1, then we have a right-hand side. Oh, whoops. I did have that copied. Here's the right-hand side. Otherwise, we just use the type information that was on the left-hand side, but that type information itself is optional. So I think we need to just double check. Again, we need to double check this because it might still not be available. So it's like could not determine type of, something like that. If we're not doing an assignment, then we need to have a type annotation to know what type it is. Okay, I think that's pretty good. Scope, we don't need to do anything. And if and for, I don't think there's anything to do. Type check statement, I don't think so. Procedure. Yeah, I guess we sorted that, huh? I think we're at the point where, well, we can't try it yet actually because the generation still has errors in it. So maybe we'll just clean up these errors and then we'll try to run it even without generation working. So I guess this is a map, right? It needs to use the name. I think I might change these. I feel like this is the stack size and this is like stack variable offsets. Yeah, whatever. Something a little more descriptive. I think that's a little bit better. So we changed this. We just put the name on the end. I have a feeling there's going to be some other places, yeah, that have the same deal. I think I didn't. I should have just done that, right? Yeah. Here again, we have this. And again. And again, and again. And again. And this also, I must have copy and pasted that. Then again and again. Are we error free? Can we run it? Yes. Invalid token at line 77. Okay. It didn't like that. Failed to parse statement. So we're going to parse. I do like these error messages, by the way. So then I go into the parsing and I go to the statement, which is here. And this line is identifier and indexed. I think I know actually, because we have identifier, but then we don't have opening square bracket. So it doesn't know what to do. It knows equals for assignment and colon for declaration. Declarations always have a colon? Yeah, they do always have a colon, don't they? Okay. So I think this is a assignment again, right? Yeah, it has to be an assignment to have that square bracket. So that should fix that. Yeah, now we just have lots more errors. Oh, index out of range. That's not very nice. Okay, parameter data types. Actually, I'm sort of surprised we don't check this. We should check, I think, because we have this procedure. Well, we have checked that it has the same amount actually already. Okay, we've identified that this is the same as that, so this indexing should be okay. I was thinking that maybe this could potentially try to find a parameter that doesn't exist. Like if the procedure has two parameters, but we're in a call right now. So if we're trying to call the procedure with three parameters and it tries to type check the third parameter, it still will do that actually. It's just saying, okay, false. So it will still do that. So that's probably what's happened. I don't know why that's, maybe it's one of the procedures that we removed. But then shouldn't we get something saying like that undeclared identifier for the procedure? Shouldn't we get this? First? I'm a little bit confused about that. We've got some bad formatting. Let's go for something a little bit easier to start with. This undeclared identifier, nothing. At line 3, column 1. Undeclared identifier, nothing. Well, yeah, I mean, it shouldn't be nothing. Failed to type check primary. Type checking, see, again, it's like type checking primary. Where's primary? Here. Should have done type check variable in this case. Oh God, where have I gone? Here we go. And it's not undeclared because we declared it here. That's why. So we assign the data type. So we are getting undeclared. But why? Type check variable. So it's a primary. Why is it treating that like a primary? It's not part of an expression. Is it continuing on from this line or something? Why would it think that's an expression? Is it because I just chucked parse assignment here? No, that should be fine, right? Parse a variable. And that parses an identifier. It doesn't go into expression parsing. But that's the parser. The type checker is where we get this. So how do we decide what statement to do? Well, we know it's an assignment, so we type check assignment. And that should be the left-hand side node. Wow, that took care of a lot of errors. that was the source of a lot of errors. Whew, that's nice. Okay, this is more like what I was looking for right before. Undeclared identifier +1. That makes sense because I took those out. So this someone +1 just doesn't, that's just testing these built-in procedures, doesn't matter anymore. And this is also +1, and this is all just, I don't think those variables were used after that, so it's probably just fine like that. And then we get an out of, because declaration, the right-hand side is optional. We didn't take care of that in our generation yet. Well, we haven't done anything in generation, so that kind of makes sense. What the hell do we need to do in generation? What do we need to do in generation? I guess we'll start a declaration. So there might not be a right-hand side. And the right-hand side is like the assignment part. So I guess this is the assignment part. Well, this needs to happen regardless. We need to do that. So this is the assignment. So let's say if the children, if there's more than one child, then then we do this. We generate the expression and we move the result. So the top of the stack, yeah, I think that's fine for now. We're not doing anything to do with arrays at this point here. Like we're not assigning an array. We're not assigning to a part of the array. Yeah, it's that's totally fine for now. The data size. The data size should be multiplied by the length of the data type. So we allocate space for multiple elements. Yeah. Let me just go up. Oh dear. Oh dear. I don't think we would have lost anything. I hope. No, that's what I just did. Wow, that was crazy. Yeah, I just wanted to go up through. So scope, no, for, if, statement. I feel like all of this stuff, or procedure might have something. Generate program. Stack size. So this here is where I think we need to multiply by the length, right? We're going through all the parameters and saying what part of the stack they take up. So if we come across, oh no, but wait a minute, I'm getting ahead of myself because procedure calls, they can't take arrays. So we don't need to worry about it. We don't need to worry about it for procedures. We've done declaration. So assignment, let's just say offset. So here, this is interesting. We're saying where to assign to, and if we're assigning into an array, this variable offset is going to be the start of the array. Well, this calculation will give us the start of the array. So I think we need to add. I hope add is right because the stack is upside down and confusing. and it's the left-hand side, so we're assigning to, yeah, the left-hand side index. So the left-hand side data index times the data size, right? Wow, that's turning into a mouthful. So this is how far into the array we need to go. Index times the size of the data type. So we need to add that to our offset. This is the stack pointer plus an offset. Oops. So we need to add that to our offset. Okay, let's see how that goes. When we return, we've said we don't need to do anything here. When we generate an expression, this also is not going to have any arrays in it. But this here again is the same thing. This could be indexing into an array. So I guess it looks like it's pretty similar. Maybe we can just copy this code. So it looks like it's LH. No, the other way around. It's node index. Yeah, I think that's probably it. Let's see. With a number, it's always, you can't index into a number. I think that's it. Generate call. Yeah, I said with calls we don't have any trouble. I mean, it compiles. What does it compile to? Let's see what this looks like. That's what I'm curious about. So it's a for loop. Is it after the for loops? Yes. So this must be it here, down to this return. Declare, assign, return. Declare, assign, return. Yeah, that's it. So we're allocating 8 bytes onto the stack because that's 1 byte and there's 8 of them. Okay, great. Then we take the number 7 and we assign that to an offset of 5 bytes from the stack pointer. And we add, which I think is right. That's what we do everywhere. Whoa. Okay. No, we have an issue. I think, remember we initialized to -1. So if we multiply -1 by the size, because we're just multiplying the index by the size, right? Where do we do it? Here. We're multiplying the index by the size. But if we're not indexing, then that's going to be -1. So I guess somewhere in type checking, maybe when we type check the variable, so here we've established, this is why we needed the -1 to do this check. So I wonder if that's not even going to be needed in the future. But now let's change it to a proper index and then do this check. So if the data index is -1, then the data index should actually be 0, right? So there's no offset. And now that we've converted it to the proper index, this should still hold. So then, yeah, I think this is where we were having the issue. So that looks much better now. Don't have this plus minus business. Okay, and let's come back to here. But yeah, so these, what I was trying to get at was that these were offsetting by going plus. So I think it's good that these also offset by going plus, offsetting into the array. So that's offsetting by 5. So I guess that's index 5. We're assigning 7 to it. Then we're taking the value at index 5 and assigning it to index 3. And then we're taking the value at index 3 and we are doing an exit syscall. So we should exit with 7. Oh God, I've got all sorts of crazy stuff there. NASM LD, damn it. Out, yeah, there we go. LD out. Whoa, I did the wrong key combination there. And echo. 7. Sometimes when things work the first time, it makes me suspicious. Well, I think we could also do this. Or 7 to the power of 3. That's too big. So let's do 4 to the power of 3. So 4 times 4 times 4. It's got to be under 256 because that's how high exit codes go. So we saw this was 64. Let's build that. Incompatible types. That's right, we had bad formatting of the incompatible types. That should be an expression, I thought. Oh, type checking. Type checking expression. Here we go. So data types was just strings. Now it's not. So now I guess we want to get data type names. And can I say data types dot length or so? Oh, that's right. It's, I don't know. Can I do this? Well, I guess it's hard coded to 3, right? I guess I'm just trying to do less of these dynamic arrays if I don't have to. And then for data type and data types, we might need the index also. Data type dot name and data type names. And this is also repeated up here, right? Incompatible types, I8 and I32. That makes perfect sense. Let's just make this an I32. Incompatible types, I32 and I32. Unsupported register size. Interesting. Unsupported register size. And I32, I32 is a problem. I guess it could be... No, but they can't be array types. we would have got an error before that if they were not indexed. They must be indexed if they were arrays, which means that this is enough type information. So why would I32, I32 be? I guess when we type check, when we coerce, we check length against length. We check length against length, but up here, I think, like I was saying, I don't think at this point in an expression, we've established that it can't be a whole array we're dealing with. It can only be a single element. So does the length really matter at this point? I guess, where is it, type checking? I guess really what we want to say is whether either of them are full arrays, and it's not possible yet. They can, when we're coercing, at the point when we're coercing, we know that they cannot be arrays. Okay, so that's 0 again. But does it make sense? So now this is the return. It's a bit more involved because we have this PAL32 that we're calling. But before that, we need to get this and this to pass in. So 4 is, oh no, it's allocating space. 4 bytes. 4 bytes and 8 bytes. Oh yeah, because I think PAL32 actually has 4 bytes. Sorry, it has 8 bytes here and 4 bytes there. Yeah, okay. So we're grabbing plus 12. These numbers have jumped up now. Oh, because they've jumped up because the number is bigger, so the offsets are also bigger. Okay, so this is 12. This is what we just assigned to in our array. Allocate some space, 4 bytes for it, and then put it onto the stack. Then we take the number literal of 3, allocate space for it, and put it on the stack. And then we call PAL32, which should use those things that we just put on the stack. Then we clear them from the stack, and then we do our exit call. Then we do our exit call. Oh, this is the return value of the procedure call, and then this is the exit. Okay, and it should exit 64, I think we said. 64. Okay. All right, I'm happy with that. So let's stop there. We've gone a little bit long, 1:14. There's some kids playing in the hallway. Hopefully that wasn't too distracting. Yeah, cool. All right. So we've got arrays. We can play with the individual elements of arrays. I think next time we need to get into like copying full arrays. And possibly at the same time, we might get into pointers, because ideally when we pass arrays around, we don't want to be copying them a lot of the time. You know, our use case that we're talking about eventually doing on the GPU and the CPU is where we pass in a couple of arrays as parameters, and then we run a kernel for each index. And we don't want to be like copying the arrays in and then at the end copying them back out again. So pointers are important. Maybe that's a good thing to do next time. Dealing with full arrays and also pointers to arrays, or pointers in general. But thanks for stopping by. Take it easy. Have a good one. Ciao for now.